Thank you. So I want to start off with a quick poll. Who's convinced they need to go down the path of adopting cloud or investigating cloud? Show of hands. Okay. So not everybody. So some of this will act as affirmation for those that do. For those that don't, this may help to convince you. I want to start off quickly by sharing a quote that I read recently. It's by a guy called Dave Turak, who works for IBM in the high-performance computing and storage arena, same as myself. And it goes something like this. In 2003, the human race had produced 5 billion gigabytes of information. That's 5 exabytes of information. Last year, we produced the same amount of information in 2 days. By next year, it's estimated we'll produce the same amount of information in 10 minutes. If you don't think you need cloud, you're wrong. You do. The traditional ways of dealing with this information growth and this information explosion simply won't do anymore. So, to introduce myself, I'm Glyn Bowden. I'm an enterprise infrastructure architect with a company called NetApp, who are actually a storage vendor. We sell storage equipment. So I do have a stake in the game for this. I'm here today representing the Storage Networking Industry Association, though. And who we are is an organization that is set up to define standards and to define some education. So we realized that the market was heading in several different directions and that it needed some kind of governance and guidance to line people up and make sure we're all playing the same game and speaking the same language. And it's more about empowering end users and consumers of the technology to understand what it is that's being sold to them, why they are interested in buying it, and what measures there are around that. So to crack on, this is the tutorial we have today is about building the business case for cloud. Now, I'm sure today, being around cloud and cloud in the enterprise, you've already heard a lot of definitions for cloud. So I'm not going to try and redefine it, and I'm not going to enter into that war. It's a very tricky subject. So we do have some, being a tutorial that we give in various different things, there are some risks involved, apparently. So we've already very briefly covered what the agenda is going to be. We'll look at popular use cases for cloud. We'll look at the various types of storage cloud. Being a storage organization, I will focus on the storage elements. That isn't the only element to cloud, I understand it, but I see it very much as a foundation to everything else that's being enabled with cloud. So we do need to understand the basis for this. And then towards the end of the presentation, I'll talk about what SNIA have been developing in terms of standards that helps solve some of the problems that we've already heard about, including in the last couple of presentations, around security, around sharing things, and around generally consuming from multiple sources of data. So this is a brief definition of cloud storage by some of our peers. Again, as I said, I'll allow you to read them yourself. I'm not going to go through each one and define it. To me, a cloud is just a consumption device. It's not necessarily a technology. You can't go out and buy a physical cloud. It's an approach and methodology and a technique for consuming IT services. So there are various flavors of cloud, and I've heard them mentioned at least once today, so you may have an idea, and for those that have heard this before, I apologize, but we tend to classify them in 3 different ways. There's a public cloud, a private cloud, and a hybrid cloud. So I'm going to go through and define what each of those are in a bit more detail. But essentially, a private cloud is something that you own and you have control over. Your organization controls the IT providing that services, or controls the organization that controls the infrastructure. In other words, the equipment and the cloud itself is dedicated to you and your organization. Nobody has any other access to that to use it and consume from it. A public cloud, on the other hand, is an ever-increasing range of things. From an organization that has a service that you consume from, such as Salesforce.com or Google, to a data center that has infrastructure as a service that you consume from, but is shared amongst other people out there in the public. That's still classed as a public cloud, despite the fact you have private elements within that. And a hybrid cloud, as we'll see in a minute, is a kind of mashup of all of those. It's not necessarily where you have traditional IT services consuming from a public cloud. That's just using a public cloud with traditional services. It's having that private service, the private cloud service internally, and leveraging resources from outside of that provided to you by a public vendor. So we look at the diagram here, we can see them kind of building up. So with the private cloud, as I said, it's within the data center that you own or within a data center that you have control of, either through a third party or through your own ownership. It comprises of a couple of elements. So obviously there's firewall security, so it's within your own network, it's within the campus network of your organization. It's typically based on virtualized infrastructure. It doesn't have to be, but it typically is. The virtualization will cover all sorts of elements, including the servers, networks, and now tiered storage. So storage is something that a lot of people don't necessarily see as a virtualized layer, but it is, and it's becoming more and more so. I think the glue that holds all of that together and actually makes something a cloud and makes something a consumption service is the automation of that. If you have to plug bits and things together to make it work, then to me, that's just traditional architecture at scale. If you can go to a portal and provision things automatically and consume automatically and understand what that consumption means to you in terms of cost and availability, to me, that's a cloud model. So then we have the external trusted cloud. This is still private cloud. This is something that's dedicated to you. So if the physical infrastructure is owned by another organization but dedicated to your own organization, then it's a private cloud. If, on the other hand, the service provider is an external service provider that hosts clouds for lots of people and you just have a small slice of that, then it's a public cloud that you're consuming from. When you have the two intermixed, as I said, that becomes the hybrid cloud. So you can see where hybrid kind of forms here. And then we have the public cloud at large, where you have services where you're consuming from multiple sources at multiple times. This can be based on application, based on various services that you want. A lot of people will have things like email in the cloud or backup and recovery in the cloud, and we'll look at some of those use cases in a bit. The main thing for any cloud organization, whether it's an internal private cloud or an external public cloud, is the concept of multi-tenancy. This is a well-known term. It's not something that's been introduced with cloud computing, and it's typically been known in application environments and environments where shared resources are used. But what essentially it means is a consumer of that service. Now, that doesn't have to be a company. A company can be a tenant on a public cloud, but so can an organizational unit, a business unit. HR or engineering can be tenants. And so can applications within those business units. Anything that needs segregating from anything else in that infrastructure is considered a tenant by this definition. So you shouldn't just think about it in terms of it must be a business, it must be an organization. It can be as granular as individual applications and users. If you have a secure multi-tenancy, this is where you have definite segregation between the tenants. This isn't just at the application layer providing different logons to different Active Directory domains, for example. It's also at the server layer where we have management access to the physical servers. They need to be segregated, so you can't necessarily view or manage other people's servers. At the network layer, this is traditionally where we've been very good at this type of segregation with firewalls, with VLANs, and with virtual networking at that layer. And then at the storage layer, and this is where it gets tricky. The storage layer traditionally only scales well if you have large pools of storage that are accessible to everyone. In order to have segregation in those layers, traditionally we've gone with silos and very separate approaches where you have a physical device dedicated to a single tenant. This doesn't play well with the cloud story. It's not scalable, and it's purely picking up the silo model that we're all used to from recently and just stamping it out a lot of times. So there's a lot going on in virtualization on the storage layer now that does allow us to scale that more linearly, where we have shared hardware, but definite physical or definite logical boundaries between the tenants that are sat on that layer. So there are several models that you'll come across in terms of cloud. The typical one is the multi-tenant. This is where you're getting value from the cloud. The reason why most people are doing it, apart from dealing with the scale that I talked about earlier, is cost. It's got to be cheaper to have a shared infrastructure that everyone can consume from. Not just the fact that you can consume from it and bring the prices down, but the prices can be well known. You understand the infrastructure that's already involved. It's already on the floor. You can flex it easily, and there's definitely understanding of the cost and the availability of that. So typically, multi-tenant is what you'll see in the environment. It is possible to have a single tenant, where a whole cloud is dedicated to a single tenant, but it's still flexible. Again, it'll come down largely to the definition of tenant. I don't see too many of those in the job that I do. Most of it is about multi-tenancy, either separating organizations or separating applications. So again, we're reiterating that private cloud infrastructures are usually deployed behind the firewall. That doesn't have to be true. They can be the wrong side of the firewall and still have a dedicated network for your organization. That still makes them private. So long as you have control over that secondary network or that wide area network, then it's still considered a private cloud. They also should be maybe hosted by a trusted third party or an XSP, so a service provider of some kind. Again, we've talked a bit about this. It's the IT resources that are being dedicated to you that makes it private. If it's shared with anybody else or any other services, it becomes public at that point. So hybrid, again, is a combination of what we have with public and private storage clouds. You take the two services together and you'll consume them in parallel. And we'll go through a couple of examples of this. Storage tiering is one of those. So I work with organizations that do a lot of high-performance computing and supercomputing type applications. And one of the things they need to do with the data is access it very quickly. And data can be extremely relevant one day and completely irrelevant the second day. It doesn't mean that the data, once it becomes irrelevant, becomes valueless. A lot of times, and with certain organizations that I've worked with, that data needs to be recalled at a later date when an algorithm changes or when something that influences the value of that data changes. And so you do need to bring it back. So you don't throw it away, but you also don't want to keep it on the most expensive tier of storage that's providing the fast access to your computing environment. So what people have traditionally done is ferry it off to tape, back it up somewhere, which is a reasonably valid argument, apart from the fact that there are a couple of horror stories around tape whereby it's on there, but you're not validating it's there. To give you one example, I used to work for a large government organization that held a lot of data on tape, and an incident occurred that meant a lot of that data was suddenly become relevant again. When we walked into we tried to recall the tape or the data from several hundred tapes, and nothing was happening. So we went to visit the tape robot that was responsible for picking these things up with its arms and putting it into the various drives. And we discovered that all of the labels for over 3,000 tapes were lying on a neat pile on the floor. We had no idea what was on any of those tapes anymore. So essentially what we had to do was manually index them, and we had a whole weekend that got dubbed Operation Pritstick, recovering them. So tape isn't necessarily the right answer for this, is my point. What you can do is you can employ a hybrid model. So if you're using a private cloud to drive your supercomputing environment, your high-performance computing environment, the hybrid model could be, once the data's been used and once the data's lost its value for that moment, push it to a cloud vendor. Push it out onto the clouds to be stored somewhere else, somewhere away from you, but where it's being validated and verified every day, where it can still sit on spinning media, and where it's their responsibility to go on checking that data is existing and happening. You have service level agreements around the reprovision of that data. At that point, the cost of holding bulk amounts of data gets pushed onto the secondary vendor or the cloud provider as opposed to your own organization, which actually is a lot cheaper. The same thing happens with backup and restore. One of the big, I work a lot with investment banks as well, and one of them had a problem with backing up of laptops. So when people were working on their desks in the office every day, which is a traditional business model, everything was fine. You plug your laptop in and you can walk away for the first 3 hours of the day and have a coffee while your laptop sat there and died while it was trying to back up. It's a common thing. More and more people are working away from the office. They're either working at home or they're mobile working, where they're working in any office around the globe. And what was happening to some of these environments is the backups were happening on their laptops, but back to their source office. So I was working with people in Zurich that were having their laptops backed up back to London or back to Chicago, which didn't do much for the bandwidth and meant that the 3-hour coffee turned into a couple of days off. So what you can do instead is switch that backup destination to the cloud or to a cloud provider that provides desktop and laptop backups. This means that you can back up now from wherever you are to the nearest node, and the data gets shuffled around in the background to be local to where it needs to be or replicated around the globe. The point is the backup mechanism now selects the nearest point for you and will back up to that. It doesn't solve the problem of the first 3 hours, but at least it eliminates the couple of days that you're going to get. And it means that the data travels with you around the globe as you travel. So that kind of covers the storage tiering and backup recovery. Archiving is very similar to what I've already talked about in the storage tiering. It's moving the data that's less relevant into a cloud store. The one that's less common, and we see less at the moment, but I think will pick up more and more, and there are examples of it which I can talk a little bit about, is the cloud storage for actual computing. When you're doing computing or compute-intensive operations, you generally want the storage to be local to the computing resources so that the fetch doesn't have to slow the process down. When a processor asks for data to churn through, it doesn't want to have to bring it back from another country or bring it back from a remote store across a slow wide area link. So generally, you have the storage tied very close to the compute resources. It's beginning to change a little with the introduction of a couple of the the kind of big data analytics solutions such as Hadoop and MapReduce and that kind of thing, then the data is now able to exist elsewhere and be pulled in to the compute model. So Amazon, for an example, and this is no endorsement, have recently launched the Amazon Analytics web service, whereby they have Hadoop that scales it, across their infrastructure, where you can place data in, it'll do the compute and then come back. And that's a form of cloud computing, where you're actually pushing it into the cloud, and cloud storage for computing. The difference is that compute resources are also moving into the cloud. It's not just the storage anymore. So rather than holding large compute farms locally, they're now there out there on the internet and able to be consumed when you require it. The biggest use I've seen for that at the moment is when you're bursting beyond your own existing capacity. A lot of organizations that need that type of computing power maintain it locally anyway. I've worked with a couple that don't and consume only from the internet, and they tend to be startup type organizations, and that's a great way of getting that type of computing power for a very low cost. But typically it tends to be bursty. So when you reach the limits of your organization's compute power, which can happen once or twice a month, depending on kind of bulk operations that are generally regular, then rather than buying and subscribing to the model where you have to purchase everything to do the highest productivity, you purchase for the mean and then you burst into the cloud to provide you the resources that you need for those extra workloads. It's a much cheaper way of consuming IT resources. So the services that you have are often tied to the applications layers and services that you have internally. This is the kind of software as a service or platform as a service type storage approach. This is where they're not necessarily giving you access to the storage as such, but there's an interface in between, such as the backup client in the case of the laptop backups we spoke about. That's where you're actually consuming the software, so you're not having access to the resource pool in behind. That's fairly common, and I think that's going to be the way most people will initially consume from the cloud. I don't think it's going to be a case of there's large pools of storage, although it's beginning to happen in the consumer space. By show of hands, who uses G Drive or Dropbox or anything like that? Yeah, so it's a fair proportion. So it's beginning to happen in the consumer way, and that's driving IT thinking as well. I know in my organization, there are certain ways that we need to deal with data, but there's other things that we need to share amongst ourselves on a global scale that become very difficult. And something like Dropbox becomes the answer very quickly because it's easy to subscribe to, it's easy to share with your peers. This is driving industry thinking, so this is definitely something that's moving forward. The consumption of cloud storage at a more granular level with small capacities of a couple of gig up to 10, 20 gig, as opposed to the terabytes which we tend to talk about in the industry. And with the use of mobile devices that can't necessarily consume the tens of terabytes that we're talking about traditionally, I think that's the model that's going to pick up more, and that's really where a lot of the interest needs to be at the moment, I think. There is a misconception about hybrid cloud, and I covered it briefly at the beginning, but accessing an external cloud service from a traditional IT service or IT infrastructure internally that's not a cloud doesn't make it a hybrid cloud. So if people are trying to sell that to you as a hybrid cloud service, and that they can transfer your internal infrastructure into a cloud purely by giving you access to a public cloud, don't believe them and don't give them your money just yet. So what I'd like to do in the short time that I have, and I apologize for having to rush through this. In my day job, I take a lot of customers through the journey onto the cloud, so defining what the cloud is and how to get there. And typically it takes me around 3 to 4 days, so trying to squeeze it into 30 minutes is a little bit challenging. But what we want to do is go through a couple of use cases. We've talked a little bit about them already, so I'll rush through some of the bits that we've already spoken about. But each use case has its own requirements, and the own requirements make certain cloud models more advantageous than others. So we'll try and focus in on them. The typical ones I want to look at are backup and restore, which I've spoken a bit about, archive in a bit more depth, and application data as we see it today. And then what will come out of that is some drivers for if you're putting together an RFP or an RFI to go to cloud services and subscribe. Somebody's not happy. So starting with backup and restore. So the business problem, obviously, is it's not actually about backing up. And although many of the storage people that I talk to, typically in the administrator level, will say, oh, backup is absolutely critical. Backup's not critical. Not if you can't restore, like my tape example demonstrated. You need to be able to get the data back. So that's the important thing. So when you're looking at a backup and restore solution, you must remember the restore bit. One of the big things that have happened in cloud storage, and this was one of the first things that went to cloud in terms of people actually thinking of it as cloud as opposed to email services where people just tended to think of it as messaging. The big problem was a lot of people would back everything up to the cloud, and you'd have I've worked in organizations as an end user where they'd ship a lot of big iron in, we'd back up everything to it on the first hit, and it would get shipped off to a data center locked in the bottom of a mountain somewhere. And then we do incrementals to it, which was great. It was very little bandwidth required, and everything was being protected. What wasn't great was when we needed to get that data back. It's in a mountain, and it's a long way away, and we don't have the kit local anymore, and we need to do a full restore. At that point, it becomes painful. So at that point, we need to start looking at options. The traditional approach in this is obviously backup software and agents on all your servers locally. You back them up to a dedicated data system. Typically, it's been tape. It's more and more it's becoming disk because of there's some efficiencies in that. And it's usually on premises. So if your premise does have something unpleasant happen to it, so does your tapes and so does your data. So if you're backing up locally in this way, then at least do consider backing up to a different premise if you can. The cloud approach is, as I said, the agents will now select the local backup target within the metropolitan area, possibly, to send the data to as a platform. So you'll consume storage outside of your organization and back up to that via the client software. The difficulty, as I said, is there's usually high capacity of amounts of data to shift, and there's latency in getting that data to the place and from the place. So this isn't perfect yet. There are some standards that SNE are working on that helps with this, but we're still in our infancy with cloud. We're still getting the networks and support that will actually allow a lot of this to happen. But definitely, I'll talk about some standards that we've developed later. This is great because what it does allow is the data to be in different places. What can happen, and what a lot of the people that I've worked with will happen, is you'll back up to a single location locally, and then it'll get replicated around the world as the data requires. One of the guidelines we should state when we're talking about this is do examine your data and see where it is legally allowed to sit. I worked with a Swiss banking organization whose data could not leave Switzerland, and when it was found out, one of their cloud backup actually exported it to Chicago so that American intelligence could get their hands on it. It wasn't popular. So do make sure that data that you're backing up is relevant and is allowed to sit where your backup provider says it can sit. But this is a huge advantage when you're looking at cloud. So why would you choose cloud? Well, obviously, as I just said, it does lower the cost. The maintenance of the equipment, the maintenance of the media is all gone and it all becomes somebody else's problem. There's also, the cloud seems to be this infinite capacity. The people you're backing up to or the people that you're consuming from have a much greater economy of scale in terms of purchasing the storage and the equipment than any organization does, unless you're somebody like Google. So you definitely have the economy of scale. So they have this ability to expand and expand quickly. It doesn't mean you have to call your vendor up and have them cut a quote for you. You have it signed off, and then suddenly the tin will arrive, get commissioned by your storage guys, and so on and so on. You'll phone up the organization, or more importantly, the monitoring will notice that you're filling up and purchase you some more capacity. The capacity planning is happening by somebody else, and you shouldn't run out. In terms of requirements for latency, it needs to be low enough to beat your backup window. There's a lot of technologies locally, including things like snapshotting and that kind of technology, that allows those windows to grow beyond what they traditionally are, particularly on the database front. But you do need to be able to complete the backup within a reasonable amount of time so that you're not necessarily spilling into the next window. One organization I found actually provided a bus shuttle service where they would collect data from you that was backed up to one of their devices and take it away in a shuttle bus. That's more important for restore, I find. So there are organizations that will ship kit to you with your data on it when it's needed for a restore. So look into options for that as well. In terms of manageability, it's a backup client. You need to manage it in the same way as every other backup client. I'm conscious of time, and I'm getting between you and winning iPads, so I'll speed. The advantage, obviously, as I said, it's lower cost. The charge back to the business unit is one that often gets overlooked, but it is actually a very important one. Backup traditionally has been a very hard thing to quantify. You know how much data exists in your file system, but you don't necessarily know how much data it takes up when it gets to the backup service. When it's on a tape, it's sharing those tapes with other services and other organizational units within your business. So to say that you are consuming this much data is very tricky. When you're backing up to something like a cloud service, it will report on each backup job and the capacity required by that backup job much more granularly. And the billing can actually happen back to that department based on the recognition of the ID of the backup client. So charging back becomes very simple. There's also a shift of burden of meeting SLAs. onto the service provider. So at that point, it becomes their business to make sure that labels haven't fallen off their tapes, or you don't hold the tape up and you can see clearly through it. So it becomes somebody else's problem, and because they're doing it at scale, they tend to have the frameworks and the methodologies in place to protect that. Again, it's about capital investment. You're not buying all this kit and equipment to work at peak all the time. You're using somebody else's. We've kind of been through those already, as I've talked. So we'll talk a bit about archive, and I'll whiz through archive because it's very much like backup. The main requirement for archive really is the retention of the data. Backup usually is a retention time of maybe a week, maybe a month, and then it rolls on and on. Archive tends to be something that you want to keep around forever, up to 100 years in some cases, particularly around things like health data and that sort of thing. So the archiving and protecting that, particularly in a compliant way, becomes very difficult. To maintain it as your own organization is very hard because you then have to have kit that becomes immutable and all this kind of stuff on site. So that's the traditional approach. The cloud approach is, again, sending it to an archive service, so there'll be some kind of client portal where you'll push it out. Again, when looking at services that are providing this, do look at their SLAs, do look at what kind of legal responsibility they're taking on themselves. As was pointed out earlier, the general definition tends to be, not our problem, Gov, it's you. You own the data, it's your problem to make sure it exists still. There are some out there that have more fuller SLAs than that, so do look around and make sure that when you're talking to the legal department, you fully understand where the onus lies on to protect this data. So the requirement is low cost. You've got lots of this data. You don't want it to be expensive to store. So it's going on the cheapest type of storage you can find. It has to be high capacity. There's going to be a lot of it, and you need to be able to keep it around for a long time. As I said at the very beginning in that quote, the amount of data that we're generating, not only as businesses but as individuals, is going through the roof. So we do need methodologies to keep that in check. Latency is less important. You don't so much care about this data. You're keeping it around forever, but you're not necessarily going to need to pull it back every day. That being said, there are a few edge use cases where it is critical. Something like medical is quite critical. If you have an accident and you need your data pulled to you wherever you may be, and this is more relevant in the US at the moment, where hospitals share data more frequently or more freely with each other, then there is some kind of SLA that you need to get that data back quickly from the archive. So it's no good locking it in a tape and then locking it in a filing cabinet, then locking it in a mountain. In terms of manageability, the most important thing you need to do with archive data is index it and understand it. It's no good having a huge archive of data if you have to mine it every time you want an individual item out of it. So make sure when you're putting it into an archive of some sort that it is indexed, you do understand where it is, how long it's going to be around for, how to get it back, and more importantly these days, that it has been destroyed when it needs to be. There's a bit of a failing going on at the moment with a few organizations where they've had an archive of data and the assumption has been it's far easier just to keep everything. And then a Data Protection Act request will come in and ask for data to be removed or deleted, and then that company has to go and find that information and actually delete it. Also with litigation, trying to pull emails and things out of an archive can be a bit of a pain without any kind of indexing. So in terms of the cloud archive advantages, again, it's much lower cost. The SLAs go to a cloud provider, very much like the backup. One thing regarding this, with archiving, one thing that people tend to overlook is the need to maintain the technology. So if you're saving something to a disk system now, that disk system is unlikely to look anything like it does now in 100 years' time when you want to get that data back. So that usually drives huge migration processes of moving from your existing archive data pool to a new one in order to perform a technology refresh. This method will hopefully put the onus on somebody else to do that, freeing up internal resources to do things that matter for your business, as opposed to planning how to maintain your archive. Again, we've talked about the various styles, and they're exactly the same as the backup ones. This is a very good option for hybrid. It's a good candidate for a hybrid cloud. We tend to have cloud services privately, and then the archive will tend to be somewhere public. So application data very quickly. The business problem is, again, applications have temporary and permanent data, and it's all a bit of a hodgepodge of what it is, and it's all shoved together, and nobody really understands. So what tends to happen is we keep everything, and we keep it on the fastest spinning disk we can possibly get our hands on, and it's expensive. So you can see the traditional approach to this is chuck a local disk box in there, connect it up with the fastest SAN and networks you can get, and away you go. That doesn't necessarily work, and it's not going to work at scale, and it's not going to work going forward. So the requirement is, in terms of cost for this, most organizations are willing to spend a bit more. They understand that there's a need for low latency, they understand there's a need for high performance and high availability. So that costs, and you have to accept that when looking at this from a cloud model. It doesn't get any different for the cloud than it does for local. In terms of capacity, there's usually a set limit, but it does grow and shrink depending on the application and how that evolves. So there's no one easy way of saying what your application is going to consume. In my business as a storage vendor, I go into a lot of organizations and look into their storage environment. And I've come across environments where the database administrators tend to be the ones that scope the capacities that are required. I'm sure it's the same in a lot of organizations here. And you'll ask a DBA and he'll think, well, what am I not going to grow beyond? 50 gigabytes, so give me 50 gigabytes. And what tends to happen is his application, for 90% of the time, consumes around 7 gigabytes. That's a lot of wasted space that sits there in your environment doing nothing that you're paying for to maintain. So what we need to do now is introduce flexibility into that, to provision at demand as opposed to provision at what people are asking for. And by demand, I mean demand by the application. So long as the capacity management is put in place that you can scale and not run out of capacity, there's no more need to give the DBA what he's asking for, essentially. You can lie to him, and there are many ways of covering up what you've done, but traditionally you'll build to what's actually being consumed as opposed to what's being requested. In terms of latency, then it does need to be low latency, usually on the compute layer. Often you're going to require some kind of edge acceleration, so there's some clever things you can do with networks, particularly with edge switches and routing, and pulling from multiple sources that allow this to be a little bit better. And again, there are some standards coming on that will deal with this, and when I get to the last slide, I'll talk a bit about them. Geographical distribution is more important when it comes to compute environments because, as I say, they need to be very near their compute. In terms of manageability, this is probably the most important one. You do need to be able to flex it. You do need to be able to report on it well. You do need to understand what's going on within it. So the advantages of a cloud, again, lower cost. You sense a theme with the cost thing here? Yeah. We're shifting the burden of the SLA again, so there's a theme with the responsibility. And you're no longer having the same IT complexity you used to have. Rather than having a very complicated infrastructure and environment to support your compute, it now becomes somebody else's problem, and there will be a well-known way of communicating with that service and consuming from it, as opposed to having to develop a whole host of different interfaces. So in terms of an infrastructure as a service, and this is the way a lot of people will initially approach cloud is, well, can I just hire the kit from somebody else and consume it as an infrastructure? So the questions you have to ask when you're looking at that kind of thing is, do I want to be multi-tenant or not? I think if you're looking at cost as the main driver for doing this, which most people are, then multi-tenant is pretty much your only choice. If you're looking at single tenancy, again, you're looking at dedicated architecture and something that's going to get very expensive very quickly. The other thing is cloud lock-in. This is something that SNIA can help with, and we'll talk a little bit about it in, I think it's the next slide. When you use a cloud service, if they have their own unique set of ways of interfacing with them and their own unique protocols, it's very difficult to get out of that and move to another cloud vendor or move to any other vendor or bring it back in-house even. So when you're looking at services that might provide this to you, make sure that they've got open standards, you understand how to get the data in and out easily, and that the agreement is there up front, that the data is yours and you're able to retrieve it and bring it back to yourself at will. So this is generally driven around APIs, which I'll talk about in a second. Evaluate whether it's as efficient at large scale as doing it yourself. So if you are an organization that does need thousands and thousands of computers, then it may be that it's far more valuable to you to build that in-house and have the teams that you already have and the infrastructure that you already have just refactored into a private cloud. It's not necessarily going to be cheaper to go out to a public provider. Look at it over time, though, because I've seen the math change drastically when you get to sort of 5 years and beyond. In terms of SLAs, each of those requirements will have a set of SLAs around it. It's far too complicated to go into each one now, but ensure that when you're looking at the data, you understand what the data requires and what requirements will come out of the actual consumption model that you're trying to drive towards. Security is another big one. We've just had a presentation all about that, so a lot of that plays into this as well, and there are models coming on that will allow you to select via security. And staffing efficiency, so do you need as many people to manage the interface with your cloud provider as you do to manage the infrastructure? If you do, either something's going very wrong or it's not for you anyway. So assess where the efficiencies actually lay. So this is our only geek slide that we have. What this is trying to show, and this is the final slide, is the organizations that are consuming the cloud are there on the left, and as they move right, they're kind of going through the various technical domains, through the consumption layer in the middle of the cloud provider, and then they have the services wrapped around the outside of that, so the auditing and the administration around that. So I said all along that SNIA were able to help with some of these problems, and the question is probably all in your minds, well, you haven't said anything that's helpful yet. What we're doing is in the cloud broker space there. So we've come up with a standard called the Cloud Data Management Interface, or CDMI. And without getting into too much technical detail about how it works, it's essentially a standard API that's being adopted by a lot of different cloud vendors and storage vendors now. And it's a way of using metadata to tag objects of data with protection information, with security information, with requirement information. So for example, I can tag a medical record that the guy lives in a certain location. The data needs to be protected in at least 3 different locations, and it should last for 95 years. What the service broker will do then is go to all the CDMI-enabled brokers in the environment that it knows about and query the capabilities of each of those services to say who is capable of looking after this data, who meets the requirements, who's within the geography, who has a security model that I'm looking for, and when you do have the data, you need to keep it around for this amount of time. It'll select as many as it needs to in order to have the kind of duplication requirement met. And that's just kind of one basic model that we're looking to at the moment. The metadata itself will also describe the object in the terms of an index. I've worked with, or I'm doing some work at the moment with a few legal organizations that have huge pools of documents that they don't know what to do with. And we're putting them through various processes that are doing index clustering and archiving. And the data itself is getting tagged with metadata that then gets spat into a CDMI broker, which will decide not only where it goes, but also how to retrieve it when you're looking at things based on those indexes. So there's a lot of interest in this technology at the moment. It's in its infancy. We're going through several standards bodies at the moment. So we're talking to the British Standards Organization. We're very far down the road. We're getting an ISO standard out of this. And we've got an ASCII standard in the US. So that's pretty much it in terms of the content. The main takeaway really is cloud is extremely different from managing local services. There's a whole lot of understanding that needs to happen about the way your business works, the way the data works within your business, and the value of that data to your business that you need to understand in order to select an appropriate solution in an appropriate place and cost. The industry is still in its infancy. We're all learning. As a vendor, I hear things that scare me about people that are adopting this, and it's my job to help them through that. So it is still in its infancy. We're expecting a lot more developments in the anything as a service type protocol. The standards that we're developing are designed to help that. If there are specific requirements in your industry that you think could be addressed by those, then feel free to come and talk to us. We're at SNIA.org in the US or SNIAEurope.org in Europe. And we're always looking for input. We've got a lot of member organizations that typically have been vendors, but we're trying to reach out more to service providers and service integrators as well as end users to find out really what the requirements are in driving these forward. We don't think we've got it perfect, but we're certainly making headway, and it's the most advanced solution in the industry currently. So if you do have any questions regarding this tutorial, then I'll be hanging around for a little bit anyway, and we'll have a bit of a Q&A if there's any time. Otherwise, then feel free to contact us here. The guys mentioned in the purple are the guys I will thank for putting together the tutorial in the first place. We each tend to deliver each other's tutorials in this. So that's it. That's all for me. Is there any questions?